This video is going to be all about polynomial functions, which are functions containing non-negative integer powers of x. So for example, we could have a function such as 2x cubed plus 3x squared minus 4x plus 7 is fx. So that's okay. But if we had square root of x, that is not, because the power of x in this is 1/2, so that is not a non-negative integer, and 1 over x, so that's x to the power minus 1, so that is a negative integer, so that does not count in this definition. So these are not polynomials. And so let me just show you a fancy polynomial function. So how about if we took the function, let's move it over a bit, fx equals x to the power 7 plus 2x squared minus 5x plus 4. And so I entered this into a program on the computer, and it looks like this. And there are ways to kind of work out where the turning points are and stuff, but we're not going to worry about that today. So here's an example of, this is an example of a polynomial function. But the polynomial function that I do want you to have a good grip on are quadratic functions, sorry. Quadratic functions. So these are polynomial functions where the highest power of x is 2. So the simplest one the simplest polynomial function you could have is fx equals x squared. But we could have more complicated ones. It could be 5x squared, it could be x squared plus 2, etc., etc. Okay, so fx plus squared, fx equals x squared, so that for x goes to x squared. So let's just have some examples. So 1 would go to 1, 1 squared is 1, minus 1 would also go to 1. Similar story for 2, goes to 4, minus 2 also goes to 4. So here, 2 different x values give the same y value, if you like. That's okay, it's still a function. Just wanted to make that point. Okay, and then let's just do 3, which gives us 9, minus 3 also gives us 9, and then 0 gives us 0, that's important. Okay, so now let's draw the graph for that. So we're not going lower than 0, so we don't need to worry about that. There we go, so we're going 1, 2, 3, minus 3, and then here's 0, and then we're going to go all the way up to 9 here on the y-axis. So here's our x, here's our fx, x squared. So let's draw these points. So 0 gives us 0, 1 gives us 1, it's about here, minus 1 also gives us 1, 2 goes to 4, and minus 2 as well, and then 3 and minus 3 give us 9. Okay, so then the function looks oh dear, a bit like this. And this is the general shape of the quadratic function. So let's just make some general points. So quadratic functions. So they always have this same general shape. This kind of shape. So a bit like that. So the lowest point on the graph, we call it the turning point. And that is when x equals 0. And the shape of the graph is symmetrical around this turning point. But different things that can complicate the quadratic function and move it to one side or the other, or up or down, and we'll look at that a bit later. But this is always the same general symmetrical shape of a quadratic function.